I'm going to demonstrate the new computer-controlled inverter system for the Carousel. Only one Star Trek reference on this one. Okay, so we have two keys. We have the operator key to enable the panel before they can start the ride, and we have the maintenance key for powering on the system. It's a latching relay, then you can remove the key. Once the system's on, the only thing I can do is turn on and off the lights. It's on a delay of 7 seconds just to prevent a surge. On and off, I can turn the lights on from the button. I can also turn the lights on and off from the wireless remote. It's a two-way switch, so. Also, enable the system. I have 15 seconds now to look around, make sure everybody's sitting down. 15 seconds is more than enough time. I don't want the operator to feel rushed. But at the same time, if the operator does leave, I don't want a little kid to come over in case the operator forgets to remove this key after 15 seconds. The PLC will shut it down. You can tell that I'm trying to stall to wait for those 15 seconds. Ride can't start. So then you have to do that. Now I can start the ride. Once the ride starts, because we still have a clutch system, it's going to ramp quickly to 30 Hertz and then ramp slowly to full speed after that, just to get the fluid clutch moving. If we look on our PLC, if it ever focuses, you can see that we have a ride countdown timer. There we go. After that timer's over, you're going to have a brake on coast time. So after 1 minute and 45 seconds, the motor's going to stop, it's going to coast, and then 15 seconds after that, the brake is going to come on. That should save your brake pad, it should save a little more maintenance, and it should save electricity. After a set time, total rides are going to go up. I think I have it set for 1 minute or 1 minute 15 seconds. It's also going to count down your maintenance timer. When that maintenance timer is up, an LED is going to light on the panel letting you know that, hey, you know, maintenance time is up. You can preset that for whatever. While the ride is running, if at any point I hit this A button on the wireless remote, it is going to trigger an emergency stop. Emergency stop not only kills power to the ride, but also spits DC into the motor to stop it a little quicker, as opposed to hitting the regular stop button, which will just kill power to the motor and engage the brake pad. No matter what I do, I won't be able to get out of my emergency stop mode until I listen to what the PLC is telling me. So if I come back to the panel, even if I shut the system, turn the system on, and hit start, stop light's going to come off, reset light's going to come on. It's telling me I'm in e-stop mode. I can't turn the lights on, I can't do anything. I have to hold the stop button down. 5 seconds, that maintenance light's going to come on. When it does, while I'm holding the stop button, I hit that, and then you look at the PLC, it's reset, it's back in regular mode, and you're ready to roll again. I try to hit start, can't do it because I have to shut down the system, turn it back on, not shut the system, but you know, disengage the panel, and then I'm ready to roll again. Now, if 2 minutes are up and the ride is coasting, power to the motor has been disengaged, but the brake hasn't activated itself yet, and I hit stop in between that cycle, any point it overrides everything. The brake will still come on. If I hit e-stop at any point, it disengages everything, enables the brake, and spits DC into the motor to stop it quicker. Power off button. At the end of the night, you hit the power off button. Your system shuts down. You know the power's off because no LEDs are on. No matter what mode you're in, there will always be an LED on that panel. When the power's off, you have a 10-watt heater for the cabinet. You can turn that on and off from the circuit breaker, but it will automatically turn on when the system is off, and it will automatically shut off when the system is on. You have LED indicator fuses, so those will light up if you have a blown fuse. We're on LEDs for all of our lighting, so I downgraded the circuit breaker for the lighting system. There's your contactor for the lighting system. There's your contactor for the panel. When you turn that key switch, it engages this contactor. I didn't want to be completely transistor heavy. I wanted to have an actual mechanical relay as a redundant system, just to have. We have our fuses for the motor, we have our inverter, and we have our main contactor. This is for our wireless stuff. That's for our wireless e-stop, and I'll show you that now. When we power on, after we power on, I have to disengage the system, re-engage the system. I hold in the reset button and the start button for 5 seconds. After 5 seconds of holding those two buttons in, my LED is going to light. I'm in maintenance mode. While in maintenance mode, anything that happens, you just go to your PLC, it'll tell you what's going on. Maintenance mode is in a different color. If you notice, emergency stop mode was in red, maintenance mode is in amber, same color of the button. Anyway, it'll tell you the only way to disable it is to power off the system. While you're in maintenance mode, wireless jog. If I don't let go of the button, it automatically shuts down. That's in case a relay gets stuck, or this button on the remote control gets stuck, or I drop the remote control in the gear. It knows, hey, you're holding me down too long, I'm going to shut down. So you have to keep constantly pressing the button like this in order to keep the motor running. So if you notice, if I let it go for a couple seconds, the motor stays on. It also is using frequency matching, so even if the motor doesn't come to a complete stop and I start it up again, the computer senses the speed, picks up where it left off. Now while I'm in maintenance mode, this whole panel is dead. Can't start the ride. If I try to turn on the lights, it'll trigger an e-stop. The only thing that will work is, of course, the emergency stop. And that was the brake releasing. I have the brake on a delay, so if I enable the jog, it'll actually leave the brake open for, I think I have it for 45 seconds, just in case we want to push the carousel by hand. If at any point I hit the other button, it'll trigger an e-stop and release the brake. Brake releases, I've triggered an e-stop, same deal, I have to hold stop for 5 seconds. My maintenance light is already on because I'm in maintenance mode, so you got to figure what 5 seconds is and then hit it. And then you should be out of e-stop mode and you can trigger again. What else do we have? If at any point somebody even turns this key, it'll trigger an e-stop. If the ride's running and they turn this key, it'll trigger an e-stop. But if they turn this key, it knocks out the contactor that sends power to the motor. So you're going to lose injection braking. But we wanted that there just in case there's multiple ways to stop the ride. So that key energizes the contactor, which brings power to the motor. Let's see, what else do we have here that we can show you? The wiring is pretty organized. So wire A is 1, wire B is 2, and so on. So for example, emergency stop is wire A. In the software, it's input 1. The lighting is wire B. In the software, it's input 2. And it's consistent throughout. So the wiring is consistent with the labeling of everything, and it's consistent with the software. So like input 9 is going to be the same in the embedded software as it is on the outside panels. So it just makes it easier if, you know, for whoever's doing your programming, in which case it's me, I really don't have to refer to manuals. I can just look physically at this panel and say, oh, I need to adjust whatever, my brake. Okay, my brake is wire 6, so that means in the software it's input 6 or output 6, depending. In the software it's fairly easy. I have it organized in a way that if you want to change your coasting time or your injection time or your run time, that it's the first thing you see inside the software when you load the program. Also, it has an Ethernet port, so if you want to do anything in the factory, whoever has this system can plug this in to their Wi-Fi. They can connect it to just a landline, and you can physically, from anywhere in the world, update the software here, change the ride time. If you have new maintenance requirements that need to be made, you can actually shut this system down if they don't sync it every year, every 2 years, whatever, however you want to do it. So, hey, we noticed you haven't changed your bearing in 10 years. You know, every 10 years you needed to check in with us until you sync your system and we know that you changed your bearing or whatever. Your system's not going to run. It's a lot like a check engine light on a car. Let's see, what else do we have? pretty sure that's it. Alright, hope you guys enjoy it. Sorry for the long boring video.